Hi, today we continue our discussion on how to divide a fraction by a non-zero fraction. Let's quickly take a look at the definition that we have here. Let A, B, C be fractions and B is a non-zero fraction. We say A divided by B equals another fraction C if this equality holds true. If A equals C times B. Think of it as A equals C copies of B. So we say A divided by B equals C if A is C copies of B. Here we are using the measurement interpretation of division as I discussed in a previous video. So let's focus on whole numbers divided by a unit fraction, such as this one, 3 divided by 1/4. So that's what we want to find out. 3 divided by 1/4 is a number and we want to find out what is that number. So we write this equation, we write 3 divided by 1/4 is C, and we would now like to find out for ourselves what is this C. If we find that out, then that means we have computed 3 divided by 1/4. So once you write this out, then use the definition to convert a division statement into a multiplicative statement. So 3 divided by 1/4 equals C really means 3 is C copies of 1/4 using the definition. And now let's look at this and this equation. 3 is C copies of 1/4 and we would like to find out what C is. And we use an informal intuitive way of finding what C is. And this is how we proceed. We know on the number line by now 4 copies of 1/4 equal 1. So here we have 3 and we are saying 4 copies of 1/4 equal 1 and 8 copies of 1/4 would equal 2 and similarly 12 copies of 1/4 would now equal 3. So here instead of C we had 12, this equation would be true. 12 copies of 1/4 would equal 3. So now we figured out C equals 12. And it's also good to do check work. Check work would mean that to really make sure C equals 12 satisfies this equation. So for that we write out C times 1/4 equals, we put in the value of C which is 12. We calculate 12 times 1/4 using our product formula of fractions. We get 12 over 4 which we know is 3. And so we conclude 3 equals 12 times 1/4. And then that really translates to, this multiplicative equation. We can also write it as a division statement. If 3 equals 12 times 1/4, that's same as saying 3 divided by 1/4 equals 12 using this very definition. And so what we have learned from this example is a method to calculate a whole number divided by a unit fraction. You can use this method and even when you don't have 3 but another whole number, and instead of 1/4 if you have another unit fraction, this way really works, and we'll slowly build up our examples until we get to a point where we really have any generic fraction divided by another fraction. So let's summarize this discussion using letters now. So in another video we did this computation, 5 divided by 1/3 equals 15, and we did that using only the definition of division of fractions. Now I want you to make a quick observation about this 15 and this expression 5 divided by 1/3. Look at what I have here. 5, instead of division sign I put multiplication, and instead of 1/3 I look at the flipped version of it, 3 over 1. 1 over 3 and 3 over 1. And it sure looks like 5 times 3 over 1 is 15. Is this just a coincidence? Well, let's look at another example. 3 divided by 1/4 equals 12. That's the calculation we just did using the definition. And now let's look at this. 3 times, instead of division, now I'm writing times. Instead of 1/4, I have the flipped version. Instead of 1 over 4, I have 4 over 1. I notice 3 times 4 over 1 equals 12. So from these examples, it looks like we can conclude, we can come up with this fact which is true, and the same method the method that we used for the specific examples also works. That argument also works for this general case. So let's summarize using letters. Suppose m and n are whole numbers and n is not equal to 0. It sure looks like m divided by 1 over n is really same as m times, now I've flipped 1 over n as n over 1, and I get equals n times n. So keep that in mind. Thank you.